हेलो एवरीवन। तो कैसे हैं आप लोग। टुडे वी आर गोइंग टू सॉल्व अ प्रॉब्लम रो- solve a problem which is rotating is the array is rotated and sorted. The problem is stating that is an any array we have given that is rotated and sorted. For example, we have this given array and we have to find that this array is sorted and rotated both at the same time. For example, there is 3, 4, 5, and if we this is rotated from the end by k, means k in this array k is 3, so it is rotated by k equal to 3, and the last three elements our last three elements are currently in first position. The before rotating this array was look like 1, 2, 3, 4, 4 and 5. But now we have to find that is that array is rotated and sorted also. So how we can find out the that is that array is rotated and sorted. If you see the pattern, what is the meaning of rotated sorted array? For example, if we anyhow find out the pivot index from where the array is rotated. For example, in this array, this is the pivot index from where this is the rotated index. For example, right now this array originally was look like 4, 5, and it is sorted by k3, and after that it became 3, 4, 5, 1 and 2, right? So this is the highest element of array, means this is the largest element in the array because the array is rotated by k from the end. So if we find out the pivot index from the first, so we will find out the maximum, the largest element from the array. After finding that array, we will iterate uh, from the from this point and to the end of the array, and always check that if any element always check that every element should be smaller than, and always on the pivot index value should be always greater than the current element, because this is the largest element before rotate point. So we have to find that. So how we can find is its previous element should be smaller than, and for example we are here right now and we will check that the index I will write 0, 1, 2, 2, 3, 4. So we are starting from the 1 index, and always check that array of I, that is right now 1, should be greater than array of I minus 1, because if this is true, it means the array is sorted, and also that then it is sorted, right? So we have to find only this thing right now, and whenever we if it will fail, for example after we reach here the index 3, and we will compare like 1 is greater than 4, sorry, 5, so it means this is false, 1 is not greater than 5, and here we will find out our pivot index, right? Now after that we have to iterate again from now. Right now our index is there. After finding the pivot index, we will move to the next element and again check that current element should be smaller than current element. For example, the index value array of I should be smaller than array of pivot idx, right? If it is true, then if it, until it is if it is true till the till whole array, then it means our array is sorted and also rotated array, right? So how we can implement the solution of this rotated and sorted array in order of n time? The pseudocode of this problem will look like bool function, in which we are checking that is rotated or sorted. Here we are getting an vector array, right? And here we have to find out that is that array is rotated and sorted. So in the first step we will find the size of array, and so we can find the size of array by array dot size, and then we will start a loop from I1 to n minus 1, and we have to check that we have to find the pivot index. And when we will find out the pivot index, when any array, when any element, for example the ith element, array of ith element is smaller than array of I minus 1 element. So the same approach we will, or the same technique we will add here. Like if array of I minus 1 is greater than array of I, it means we find out the pivot index value, and we just need to add one more thing, which is if we find out the pivot index. Right now we have this pivot index. Whenever this condition meet, then it means then we find out the pivot index of the array, means the largest element of the array, and then we will compare this 5 elements with the last element. So how we can compare right now? Where we will find out something like array of I minus 1, this is the highest element, then it should be greater than array of n minus 1 also. If this condition true, then the array is sorted, otherwise this array is not rotated and sorted. The same condition we will apply here. Like if array of I minus 1 greater than I array of n minus 1, mean the last index that has been rotated. So we have to add the not sign, means if this is, for example, here we find out the pivot index, and here in this condition if it is not true, then we will return false, right? So this is how, and after closing the for statement, and in the end we will return true. So this is how you can add this is how you so this is how you can solve the problem. So what is happening, what is happening here, we will we what is happening here now, we will see again visually. For example, as we know, this is our pivot index point, where we know that the pivot index, what is the pivot index value? means it is a pivot index value where the current ith position value is smaller than to the its previous I minus 1 value. Like I minus 1, the value is greater than ith ith index value, right? So it means it is sorted by, it is rotated by k by 3, means it is rotated from the end. And if we find out the pivot index value, it means the highest or the largest element we find out. Now we just need to check that our I minus 1 value should be greater than n minus 1 value, this from this value. If here is something else that is smaller than, that is smaller than I minus 1 for the this is, then it is true. If it is greater than this element, if it is greater than, if this value is greater than this element, that means the array is not rotated, array is not sorted and rotated array. So this is the only, so this is the condition only where you will find out the your you will check that any array is rotated and sorted in order of n time, because we are iterating from the, we are iterating from 0th index to 4th index. And we are not taking any extra space, we are taking a constant space, means order of 1. And this is the constant space complexity. And so we solved this problem with the time complexity order of n, and order of with time complexity we solve this problem with the order of n, and in space complexity with order of 1. And or I can say the space complexity is constant because we are not taking any extra space to solve this problem. Okay guys, so this is the normal and the simple solution of the rotated sorted array. We will meet in the next video with the proper and easy solution of any problem. Take care till then.